Hello everyone. Nowadays so many traffic rules are there and we all aware of that. Among them speed limit is so important and maintained by probably all of us. Do you know why? The reason is automated e-challan issued by the authority for cross the speed limit. But do you ever think how they do so without any error? Yes, it is a very useful and interesting properties of mathematics. It is nothing but the Rolle's theorem. So, at first, let us try to understand the statement of this theorem. So, in the statement it says that a real valued function fx defined on a finite closed interval ab such that fx is continuous for all x in ab, that is the closed interval ab. If dash x, that is the derivative of the function, exists for all x in open interval ab and f of a is equals to f of b, then there exists at least one value c lies in between a and b such that f dash c is equals to 0. So, few things are very important here and you should be noted. First of all, it is the real valued function and the function should be continuous within a given interval. The interval should be a closed one. Next, the derivative of the function should be exist in the open interval. That means at the boundary, that means at x is equals to a and at x is equals to b, not necessarily the derivative exists for the function. One more property is what? That at the end point, that is at the a and at the b, the functional value should be equal. If these three properties will be hold for a real valued function, then we definitely find out at least one value c. More than one value also be possible, but at least one value we will find out in between the interval a and b such that the derivative at that point c should be equals to 0. So this is our Rolle's theorem. So now we just explain the theorem geometrically so that we can understand it better. So the geometrical interpretation of Rolle's theorem for, we can say that let this one is the function fx. This one is the function fx. And as for the given situation, the function is continuous. Continuous means there is no break in the function. And not only that, in each and every point of this function, the derivative exists. What does the meaning of the derivative? Derivative means it is nothing but the tangent at each different points. Whatever be the point you can consider on this function, at each and every point we can draw a tangent. That tangent is nothing but the derivative at that particular point. And one more condition is what? That suppose a is the starting point and b is the end point. That means this is the given range basically. Not this one. Actually here this one is the given range and at the point x is equals to a, the functional value fa is this one. And similarly, at the point x is equals to b, the functional value fb is this one. So, this one, these two values should be same. fa should be equals to fb. So, if this one is the given situation, then during this journey or during the entire function, we will find out definitely at least one point. At that point, if you draw the tangent, then that tangent should be parallel to the x-axis. Better to say, if we join these 2 points a and b. So, when we join these 2 points, so this one definitely it is the parallel to the x-axis. And during the function, we will find out at least one point where the tangent is parallel to this line joining AB and hence it is parallel to the x-axis. So let us define this one through some more examples. So here is few more curves. Suppose this one is the given function. Here look, 2 points are there at which if we draw the tangent, then these are parallel to the x-axis. So we will find out 2 points here where we will find out the derivative of the function is 0. So derivative 0, that is actually the tangent is parallel to the x-axis. Is it now? Because both are parallel. So this one, its tangent means its angle, tan angle with the x-axis is 0. And the same for this tangent also. Similarly, instead of this one, if we define this function, here we will find out one point which is parallel to the x-axis. Not only that, if we just take this one, so just this one is a half circle. Here within this one, a point C will be found, and this is nothing but the point which passes to the center of the half circle. And one thing is very important here, that is at the end point. At the end point of this function specially, we will find out that the derivative doesn't exist. Yes, derivative doesn't exist. So you know when derivative doesn't exist? If we will find out that at any particular point the tangent is perpendicular to the x-axis, then at those points we will not found any tangent. Not only that, if we will have any corner point, like if a curve is like this one, so this type of corner point if we will have in a graph, then at those points tangent, such type of points for derivative doesn't exist. Not only like those corners, but if any cusp point you will find out or any cusp value we will find out in a given curve, then at those points also derivative doesn't exist. I hope you know all about these derivatives while we go for the function. Anyways, let us do some example for the Rolle's theorem. So first example is fx is equals to x square minus 5x plus 6. This one is a given function within the interval 2 and 3. This is the closed interval. Now we are supposed to verify that Rolle's theorem is applicable for this function or not. So first of all, the given function is a polynomial function, and a polynomial function is always continuous. Not only that, it is differentiable also. So the given function is continuous within this closed interval, and its derivative is 2x minus 5. So that one. So its derivative, which is again a polynomial, hence it is derivable also within this open interval. Now at the end point is at the point 2 and the 3. The functional value becomes 0 for both the cases. So we can say that f of 2 is equals to f of 3. So all the three conditions of Rolle's theorem are verified here. So that we can say definitely there exists a point C lies in between 2 and 3 in such a way so that the derivative at that point should be 0. So we know the derivative of the given function is 2x minus 5. If we substitute x for c, we will substitute that, we will get that 2c minus 5, which should be equals to 0, and that will give us c is equals to 5 by 2, that is 2.5, which is lies between 2 and 3. So that we can say the Rolle's theorem verified for this function. Not only the polynomial function, but the trigonometric functions, if you will find out, then these functions are also always continuous and differentiable. Anyways, let us do the second example. Here the given function is. So this one, I hope you can understand which equation is this one. If you don't know, then I can just give you a guess that it is a circle probably. Not probably, this is the equation of the circle. Anyways, so here given that the x lies in between minus a to a, where a is called the radius. So for this function, we are supposed to verify that the Rolle's theorem verified or not. So the given semicircle here, the given interval is minus 1 to 1 and the radius is greater than 0. So that this given one we can draw in this way. I am just drawing the semicircle. So this one definitely continuous within the -1 to +1 and differentiable also within the open interval only, not at the point this one and this one, because at these extreme 2 points we will get the vertical tangent. As the vertical tangents we will find out, so vertical tangent doesn't exist actually at these 2 points, that means derivative doesn't exist. Now at the end point the functional value becomes 0 for both the cases. Thus all the 3 conditions of the Rolle's theorem verified, and hence we can say there exists point C for which we will find out if dash C is equals to 0, and the derivative of the given function is minus of 2x divided by 2 root over of a square minus x square. If we substitute C instead of x, then we will find out this value, which when equating to 0 gives us the value C is equals to 0. So 0 definitely lies in between minus a to plus a. Hence we can say the Rolle's theorem is verified for this given function also. Now let us take one more example, and the example is now fx is equals to mod x and within the range -1 to +1. So at first let us draw the graph of the given function. So according to the given function the graph should be this one. Here this is the -1 and this one is the +1. So given function fx is equals to, we should write minus x within the range -1 to 0 and is equals to x within the range 0 to 1. So obviously the given function is continuous within this entire range, but at the point exactly 0, at the point this 0, the derivative doesn't exist, because if we take the left hand side and the right hand side derivative, then we will find out once the value is -1 and another side the value is +1. So the derivative doesn't exist at this point, so that Rolle's theorem is not applicable, because in between the interval there is a point where the given function is not differentiable. That's why Rolle's theorem is not applicable for this particular function. So these are the few examples for you. Now there are few do by yourself questions. So do these questions by yourself. So the first question is fx is equals to 1 by 2 minus x square within the interval -1 to 1. Second one is 1 minus x to the power 2 by 3 in the same interval. Then one more, it is fx is equals to 2x cube plus x square minus 4x minus 2 within the interval -√2 to +√2. One more is tan x within the interval 0 to pi, and one more, it is 1 by x plus 1 by 1 minus x within the interval 0 and 1. This particular problem for this is actually the exceptional significance, because this one is the very good example by which we can show that the 3 conditions of Rolle's theorem are sufficient only, and by no means they are necessary. Actually, what happens at the point 0 and 1, this function doesn't exist. When the value is 0, then f0 doesn't exist because this is undefined. When it is 1, then f1 doesn't exist because that time this one is undefined. So, depending upon that, still if we go by the formulas of the main value theorem, that is Rolle's theorem, then we will find out there exists a C. At that point, if we draw the tangent, then that tangent is parallel to the x-axis. So you just try to solve this one and prove that the Rolle's theorem, its conditions are sufficient only, not necessary by any means. Anyways, I hope you enjoy the Rolle's theorem and you understand. Just try to solve all those questions so that you can understand it properly. Not only in case of the speed calculation, but there are so many applications of Rolle's theorem still exist. So try to find out all of those so that you can enjoy the Rolle's theorem and feel the theorem. Have a nice day and thank you all.